So, good afternoon, all. This is Week 7 Microelectronics Device to Circuit. This is a problem solving session. I'm Arpita Biswas, a PhD scholar from IIT Jodhpur in Electrical Engineering Department. So, let's start the session. So, this is more details about me. And this is the question number 1. So, please try to solve the question and please unmute yourself and try to give the right answer. So first question is a MOS differential amplifier has gain GM is 2 milliamps per volt and RD is 10 kilo ohm. So try to calculate the differential gain. Tell me how to find out the differential gain. If GM is given and RD is given,
Ma'am, if the answer is 20 only, ma'am.
yes, the right answer is 20. Tell me how to solve.
Ma'am, AVD is equals to minus GM into RT, ma'am.
Yes, the differential gain AD equal to, and please try to solve the similar type of question, okay? And please go through the lecture before coming to this question answer session. Please go through the lecture. So AD equal to GM is 2 milliamps per volt. 2 into 10 to the power minus 3. RD value is 10 kilo ohm. 10 to the power 3, right? So what is the value of the AD? It is 20. So right answer is 20. Okay. So we are moving towards the question number 2. For the amplifier circuit shown in the figure below, calculate the mid-band gain AM. Okay, given is R SIG is 100 ohm and RG is 100 ohm and RD value is 20 kilo ohm and small RDS is equal to 40 kilo ohm and GM is given 4 milliamps per volt. So go through the circuit carefully and try to find out the answer. You have to find out the midband gain AM. Okay, please try to solve.
Ma'am,
Yes.
ma'am, the answer is 400 only, ma'am.
No, not 400. Tell me how you have calculated.
Ma'am, 1 second, ma'am. I will recheck it and.
Okay. Take your time. There is no hurry. You take your time, then I will solve.
Ma'am, I got minus 26.67, ma'am.
Yes, the right answer is minus 26.67. Good. Um, can you please discuss here how you have calculated?
Sure, ma'am. AM is equals to minus GM into RD parallel to RDS into RG by RG plus R sigma.
Hmm.
Then
Yes,
we,
like AD equal to, sorry, AM, the mid band gain. Okay, AM equal to minus of, we are taking this RG by something. This is RG by RG plus RSIG. Okay, into GM into RG parallel to, sorry, RDS parallel to RD, right? RDS parallel to RD. Tell me the value. Minus, what is the value of RG? RG is given 100 ohm. 100. Other students, please try to solve into, and this both are 100, right? 100 plus 100. What is the value of this GM? GM is 4 milliamps per volt. 4 into 10 to the power minus 3 into, what is the value of this RDS parallel to RD? This means 40 into 10 to the power 3 parallel. This means multiply this 20 into 10 to the power 3 by, oh sorry, here this way. Okay, 40 into 10 to the power 3, because this is parallel, 10 to the power 3 plus 20 into 10 to the power 3. Tell me what is the value. This is minus 26 point, please try to calculate it. 26.67. Is it clear? So next move toward the question number 3. And in channel JFET has IDSS 10 milliamps and VP is equal to minus 3 volt. Find its max transconductance. So there is the option like 0.4 or 6.67 or 7.84 or 3 million 3 ms.
Ma'am, ma'am,
Yes.
ma'am, I got the answer 6.67, ma'am.
Yes, the right answer is 6.67. So I'm waiting for more students. Please tell me, are you getting the same answer and how to calculate it? Jasmine, Hari.
Ma'am, the formula is 2 multiplied by IDSS divided by VP.
Hmm.
So 2 into 10 milliamps by 3 will get 6.67.
Yes, good. So the right answer is 6.67. How to calculate it? See, the transconductance GM is delta ID by del VGS. So from here we are getting twice of IDSS by mod of PP into 1 minus VGS by VP. So max value of the GM occurs when VGS equal to 0. VGS equal to 0. So GM max equal to 2 into 10 milliamps IDSS 10 milliamps by 3, right? The VP value, mod of VP. So this is 20 by 3 equal to 6.67 milliamps. Okay. So next move toward the question number 4. For in-channel JFET, IDSS is equal to 10 milliamps, VP is minus 5, and VGS is minus 3.5. So find out the ID.
Ma'am,
Yes.
ma'am, I got 0.9 milliamperes.
Yes, 0.9 milliampere.
Can I say the processor, ma'am? I can.
Just wait for 2 3 minutes. I'm waiting for other students also. Please, Jasmine, hurry. Try to solve. I want please at least all of you participate. Unmute yourself and try to solve how you solve this. Jasmine, how to solve? See the ID value. Now tell me how to calculate this ID. What is the equation?
ID is equal to IDDS multiplied by 1 minus VGS by VP the whole square.
Yes. So just put all this value like IDSS into 1 minus VGS by VP whole square. So what is the value of the IDSS? 10 milliamps is given here. Okay. 1 minus VGS by BP 3.5 by 5. Just cancel out this minus whole square. Okay. So the value is 0.9 milliamps. So the right answer is option D. Okay. 0.9 milliamps. This is the question number 5. Working of a JFET can be explained as modulation of the channel conductance by an electric field. First option is the parallel to the channel. Second option is the perpendicular to the channel. Third is the parallel and perpendicular to the channel. And option D is equal to 0.
Ma'am, ma'am B.
Yes, option B is the right option. Perpendicular to the channel. Next, this is the question number 6. In a BJT based differential amplifier, the allowable range of a VCM is determined at the upper end by Q1 and Q2 leaving dash mode and dash entering dash mode. So the option is cutoff active or active saturation or saturation active or active cutoff. Please try to solve. And please go through the lecture. I have already directly taken this question from the lecture video. What is the right answer?
Active and saturation.
Yes, active and saturation. Good. So just a minute. What happened? This is the question number 7. If H and FL are the frequencies at which the gain drops by dash below its value at midband. First option 20 dB, then 3 dB, 6 dB or 10 dB.
Ma'am, 3 dB.
Yes, 3 dB is the right option. Dash defines the voltage range that can be applied to the differential amplifier as input such that the MOSFET of a amplifier remains in saturation region. First option input common mode range, second is the output common mode range, third option is the common mode rejection ratio, and option D is the differential voltage gain.
Ma'am, input common mode range, ma'am.
Yes, input common mode range. Option A is the right option. Please, other students, try to solve. At least try. This is the question number 9. For a perfect match differential pair, the common mode gain should be dash and the CMRR should be dash. First option is 0, 0. Second option is 0 infinite. Option C is the infinite 0 and option D is the infinite infinite. So for a perfect match differential pair, the common mode gain should be and the CMRR should be. Tell me what is the right answer?
0 and infinite.
Yes, 0 and infinite. Option B, right? This is the question number 10. The input stage of every op amp is differential amplifier, common source amplifier, common gate amplifier, or common drain amplifier.
Differential amplifier.
Differential amplifier.
Differential amplifier, ma'am.
Yes, option A. This is the question number 11. The frequency band in which the gain of an amplifier is independent of frequency is called cutoff band, pass band, mid band, or stop band.
Midband, ma'am.
Yes, this is mid band. This is the question number 12. Bandwidth of an amplifier is defined as FH into FL or FH minus FL or FH by FL or none of the above. How to calculate this bandwidth of an amplifier?
Second option,
Ma'am,
FH minus
second
F.
option. FH
Yes,
minus FL.
second option. So this is the question number 13. For the amplifier above, um, if our SIG is 1 kilo ohm, find the high frequency cutoff FH, and here is the formula is given. I think I missed the well. Actually, I have not put it this circuit diagram. The C input is value is 47. Sorry, just skip. Just you have to find out the value. Okay. This is the question number 14. A MOS amplifier has CGS equal to 2 picofarad, CGD equal to 0.5 picofarad, and GM equal to 5 milliamps per volt. and the load resistance RL equal to 10 kilo ohm. So find out the input capacitance due to the Miller effect.
Ma'am,
Yes.
if the answer is 27.5 picofarad,
Yes. 27.5 picofarad. Hari, please try to solve. How to solve? Jasmine?
ma'am,
No, please wait for some time. I know you can give the right answer. Is yes, the answer is 27.5. But I want to please all the students please participate it. Please try to solve.
ma'am, can I say the formula at least?
Okay.
A1, AB is equals minus GM into RL, ma'am.
Hmm. So
Then we
here
have,
you have to find out the input capacitance. Tell me how to find this C input. What is the formula here?
CGS plus CGD
CGS plus
into
CGD 1 minus
CGS plus CGD
GD
into 1 plus GM
1 G.
into RL. Okay. This is the value of this CGS. This is 2 picofarad. What is the value of the CGD? It is 0.5 into 1 plus GM RL. What is the value of this GM? There is 5 milliamps. RL value is 10 kilo ohm. It means 10 to the power 4. Right? 2 plus 0.5 into 1 plus 50. Two plus 25.5. So what is the answer? It is 27.5 picofarad. Is it clear? So this is the question number 15. For an amplifier, FL is 100 Hz and FH is 10 megahertz. So find out the 3 dB bandwidth.
Ma'am,
Yes.
Ma'am, I got answer 9.999 megahertz, ma'am.
Yes. Just tell me the how to find out this bandwidth.
Ma'am, B, uh,
FH
BW, FH minus FL, ma'am.
FL. Just simply this FH minus FL. So this is 10 into megahertz means 10 to the power 6 minus 100. So it is almost 9.99 megahertz. It is almost 10 megahertz. Okay. So this is the question number 16. If the midband gain of an amplifier AM is given 100 and the bandwidth is 5 megahertz, compute the gain bandwidth product GBW.
Ma'am, ma'am,
Yes, tell me the right answer.
500, ma'am.
500 megahertz. So what is the formula? How to find this GBD?
AM equals to BW.
WT is equal to M into bandwidth. Just gain bandwidth product. Okay. Gain into bandwidth.
Okay.
Bandwidth. What is the value of this AM? It is 100. Bandwidth is 5 megahertz into the per 6. 500 megahertz. GBW. This is the question number 17. The JFET is primarily a current controlled current source, voltage controlled current source, current controlled voltage source, or voltage current controlled voltage source.
Ma'am, voltage control current source.
Yes, option B is the right option. The JFET is primarily a voltage controlled current source. This is the question number 18. The pinch of voltage BP of a JFET is defined as drain to source voltage at which the ID is 0, or get to source voltage at which the ID is 0, or get to source to gate current is gate current equal to 0, or voltage gain of JFET. So the pinch off voltage of a JFET is defined as.
Gate to source voltage at which ID equals to 0.
Yes, the right option is option B. Get to source voltage at which the ID is equal to 0. Okay. So next move toward the question number 19. So for an N-channel JFET, the drain current in saturation is given by ID equal to IDSS into 1 minus VGS by VP whole square, while IDSS is given and VP is given and VG is given. So you have to find out the ID. Here formula already given, just find out the ID.
Ma'am, is it 2.5 milliamps?
Yes, 2.5 milliamps. Already here the equation is given. So ID is IDSS into 1 minus VGS minus VP. So ID equal to 10 into, sorry, 10 1 minus minus 2 by minus 4 whole square. Ten into 1 minus 0.5 whole square. This is 0.5, right? Whole square. 2.5 milliamps. Okay. So this is the question number 20. If VGS is given minus 3 volt, VP is given, IDS is given, then find out the ID.
Three milliamps.
3 milliamps. Ma'am.
Yes, 3 milliamperes. So how to calculate is again the same equation we have to use. The ID equal to IDSS. Please solve this type of question. You are going to face the similar type of question in your exam. 1 minus VGS YVP whole square. So IDSS is given as 212 milliamps into 1 minus VGS value minus 3, and the VP value is minus 6 whole square, right? So what is the value? 12 into 0.5 whole square. 3 milliamps. Next, the question number 21. In a BJT differential amplifier with perfectly matched Q1 and Q2, if the VV1 equal to VV2, then the condition, which condition is satisfying? Like IC1 equal not equal to IC2, or IC1 equal to IC2 equal to I by 2, or option C is the both transistor are off, and option D is only one transistor conducts.
Ma'am, option A, ma'am. I see one notification.
See the conditions what is given here. In a BJT differential amplifier with perfectly match with Q1 and Q2, this Q1 and Q2 perfectly match, and also the VV1 equal to VV2. Like if there is total, the ID is flowing, and here is the Q1 and Q2 is present, this both are identical, like it's meant perfectly match, and also the VB1 is equal to the VB2, then tell me which condition is satisfying. This Q1 is matched with this Q2, and here the ID is flowing. The ID, it is ID, right? Then similar type of current is flowing or different? This is the question. Like if it is taking the I1 and this is I2, and here is the I, total the I. Now tell me, how if Q1 and Q2 are equal, then how much current is flowing through it? It is I, like this I1 equal to I2, or this I1 not equal to I2. Are you getting my point? Like Q1 and Q2 are perfectly matched, and VV1 and VV2 is also matching. Okay, so this condition is satisfying this option B. The IC1
Option B.
equal, yes, IC1 equal to IC2, and this is the half of this total I. Here the I is flowing, so from here the I by 2 is going to flow, I by 2, and from here also the I by 2, right? I by 2, because it is perfectly matched, so same current will flowing, and from here also when it is will go, it is also the I. So the condition is IC1 equal to IC2 equal to I by 2. Okay, so this is the question number 22. The parameter that quantifies noise rejection in a differential amplifier is: first option is the power gain, second is the bandwidth, option C is the common mode rejection ratio, and option D is the voltage swing.
Ma'am, option C, common mode reduction ratio.
Yes, option C is the right option. This common mode rejection ratio. Good. This is the question number 23. Differential amplifier is used to mainly because it gives the higher power gain, it rejects the common mode noise, it has lower bandwidth, or it requires the fewer transistors. Please wait for a minute. I'm coming back.
Ma'am, option D, ma'am. Ma'am, ma'am, option B, ma'am.
So what is the right option?
Option B, ma'am.
Yes, question number 23, the right option is option B. It reject the common mode noise. This is the question number 24. If the total emitter current I equal to 1 milliamps and VID equal to VV1 minus VV2 equal to 60 millivolt, compute the ratio of the IE1 by IE2. Take the VT equal to 25 millivolt.
I got 11.023, ma'am.
Okay. Tell me how to solve it. Okay, let's
Ma'am,
wait for 1 minute. Jasmine, how to solve it? Hurry.
first we have to take IE1 is equal to IE by 1 plus U minus VID by VT,
Hmm.
and I2 is equal to I by 1 plus E VID by VT, ma'am. We
Okay.
have to take two equations common and we have to solve it, ma'am. Then we get the answer, ma'am.
Yes. Hurry. Tell me how to solve it. You have to find out just I1 by I2. Just put the direct equation. Tell me, can we write I1 by I2 equal to e to the power VID by VT? Just put this value e to the power. Tell me the value of the VID. VID is given 60 millivolt, right? 60 millivolt. And what is the value of this VT? VT is given this 25 millivolt. Okay, 25 millivolt. So in e to the power, this is equal to e to the power 2.4. So what is the value? This is 11. 11 point something, or we can take the 11 near about the 11. Okay. So next move toward the question number 25. The common mode rejection ratio is defined as the ACM by AD or AD by ACM or AD plus ACM by 2 or none of the above.
Ma'am, option B, ma'am. AD by ACM.
Yes, option B is the right option. AD by ACM. This is the question. Please, all of you, hurry, Jasmine and Jen. Please try to solve the question. Please unmute yourself and try to solve the question. So this is the question number 26. Ideally, the common mode gain ACM of a differential amplifier is first option is infinite, second option is 0, option C is the equal to the differential gain, and option D is the different on beta.
Beta. Ma'am, 0, ma'am.
Okay. Jasmine, what is the right option?
It is right only, ma'am, or not?
Yes, it is right. The right option is option B, 0. But please, all of you, try to participate. Only one student or two student is giving the answer. So this is the question number 27. If the GM is 40 and RC is given 5 kilo ohm, find out the differential gain AD.
I got 200 more.
Yes.
Ma'am, I got 200 more.
Yes, 200. Hurry, how to calculate this? AD?
GM into minus GM into R.
Okay. Jasmine, how to find out? Tell me, what is the value of this AD? What is the equation?
Ma'am, GM into RC more.
Yes, GM into RC. The differential gain AD equal to GM into RC. Tell me the value of this GM. GM is 40 millisiemens. So 40 into 10 to the power minus 3 into 5 kilo ohm. 5 into 1000. So AD equal to 200. Okay. So this is the question number 28. A differential amplifier has a differential gain AD equal to 200 and common mode gain ACM equal to 0.02. Now calculate the CMRR in dB.
Ma'am, it is 80 only, ma'am, 80 dB only.
Yes, 80 dB. Other students, please try to solve. Jasmine and Hari and Jane. Please wait for other students. I want all of you participate. Please solve this question. The right answer is 80 dB. Now tell me how to find out. I'm waiting for 1 to 2 minutes because mostly in this class one and I think one another student, two student is giving the answer.
Ma'am, it is 20 log AD by ACM, so 80D.
Okay. So first calculate the CMRR, normal CMRR. The CMRR equal to, tell me the equation, how to find out this CMRR. This is AD
AD
by,
by AC,
yes,
AD by ACM.
same. So AD is 200, right? And what is the value of this ACM? It is 0.02. So what is the value is? It is 10,000, right? Now CMRR in dB. This is only the short type of MCQ type of question. I hope all of you are, you can solve. If you've gone through the lecture, then it is easy to solve this type of question. In the next class, I will put more numericals. And not only one student. I think all of you are going to answer. So 10,000. Okay, this is comma. So this answer, this is 80 dB. 80 dB. This is 29, question number 29. A MOS differential amplifier reject. First option, only one input. Option B is the differential signal. And option C is the common mode signals. And option D is the output swing.
Ma'am, C, ma'am, common mode signals.
Okay. Jasmine and Hari, what is the right option?
Yes, ma'am, common mode signal.
Yes. Common mode signals. So this is the question number 30 and this is the last question. So in the next class, I will put some more question. Actually, it only cover one 1 hour. Actually, one and two students are going to give the answer. That's why this class is almost 1 hour. But in the next class, I will put more numerical question. So please try to solve the question. A MOS differential pair has tail current I equal to 200 microamp and V overdrive voltage is equal to zero point 0.2 voltage and differential input voltage VID is 0. So find out the drain current through each transistor. And this is very simple, I think.
100 microamps.
100. But I want Jasmine, Hari, and Jane. All of you, please try to solve. How to just tell me how to solve.
Ma'am, first IE is equals to ID1 plus ID2, ma'am.
Hmm.
Then 200, IE is given as 200 microamperes, and we have to substitute 200 microamperes by 2, and we get the 100 microamperes.
Yes. So ID1 equal to ID2. Okay. Equal to ID by 2. Previously, I have shown if it is Q1 equal to perfectly match with the Q2 and VB1 equal to VB2. So the same current is flowing through this both side, and this is the half of this total current. Okay. So ID equal to I is 200, the tail current is 200. Like if that side the Q1 is present and this side the Q2 is present and this is both are the identical or match, then there is the total, this is the I current, this is the I is flowing through it, and this is the I by 2, I by 2, and same from this side also the I by 2 is going to flow, and here, and this is this called the tail current. Okay, the tail current is I. So I is equal to 200. This is given, this 200 microampere is given here, and this is the I by 2. So it is 100 microamperes. Okay. Is it clear? So in today's class, I have only taken this 30 question. So from the next class, I will put some more question like 30 to 35 question, or I'll put some numericals like this is the smaller and small numericals, but I'll put some of the like with the circuit diagram, I will put some of the question. Okay. So today we are ending the session here, and please at least try, and I hope, I expect that at least all of you will try from the next session also. Today only one or two student giving the answer. Okay, so you can leave. We will meet next Tuesday 7 to 9 p.m. Thank you.
Thank you, ma'am.
Oh, yes, if there is any question, Jen.
No, ma'am, mistakenly pressed.
Okay, 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 okay. Okay, then you can leave.